So today's date is the 1st of January 2026. The 1st of January 2026. The 1st of January 2026. Okay. The time now is time now is uh 6:45 a.m. It's London. Anyway, this guy should don't care about it. Point you care. He sounds different. So so today's video is very important video. Uh, Basically, stop recording. I'm still recording. So it's on the NSIGGI protocol. N for November, S for Sarah, I for Indigo, G for Golf, G for Golf, I for India. But it's basically on the Sparse missile model projectile system I've been working on. Guys, if you guys can make this in Nigeria, I'd be like surprised, but it's much better than what I've seen in the ballistic one. The whole purpose of it is a command and control system, like literally commanding stuff that's basically humane, sparse, and so on. Can give you food, and also you execute you. Can give you food. Which side of the missile are you on? The one can give you food or kill you. But initially, a command and control system for receiveable missile. Basically, it's a missile that's very, very powerful. It's a Sparse missile. I'm going to give you I'm going to go to going to switch to the tabs here. But before I continue, you know, it's basically organizes sovereignty, design and technology, human rights, 80 human rights missile that I've made by observing Tomahawk indirectly and indirectly. But the specification is there, so I'm going to show you the specification, which it was capable of. But I want to show you a final blueprint. Oh no, because I'm in a war unit right now, so I can prototype here, but I cannot build it because of safety issues and but I know the right people to build it. But it's basically a missile that can a cruise missile, a type of cruise missile. Okay, let's now go back to it. So, oh, this is not yeah. So it's here. So we're gonna do this too. Oh, sorry guys. So this is missile can capture it. Cool. So it can help you or can destroy you. Okay, so let's continue here. So if you go to if you go back another, if you go to github.com/O for Oscar, B for Bravo, I for India, N for November, E for Echo, X X-ray, NSIGGI as a protocol, NSIGGI underscore as a the king. Go to blog main. Just type in go to the folder NSIGGI Sparse missiles specification and Sparse missile technical analysis. Okay, so I'm now gonna go to reader mode. So I'm gonna put to read forward slash colon forward slash and now I'm reading more. So this should read it to us, but you should be actually pausing halfway because after yeah, it's there because we too code about it. So um, I don't want to give you the whole specification, but this whole specification here and say defend, deliver, intercept, aid. That is pass model. Destroy target. Okay, let me just ensure that this works as intended. No, your voice is to no, your message to voice is to I don't know social this is about missile design, but it's one of the most dangerous missiles. So uh, you find a Nigerian voice. I don't like American voices. I'm trying to find Nigerian. This is an on-the-fly system. United States, United Kingdom. There's a Nigerian voice here, guys. I know what it is. Microsoft people. So the Nigerian voice here. I just can't seem to find it. I need to go choose so I can feel the ground until I decide to do it. So, they're arguing on telly right now. Let me just use any of United States. Michelle, natural. Michelle, okay, this is Michelle is the one I use. So you can click play on Michelle's song. The voice is low. Let's slow it down a bit more. So, the NSIGGI, N for November, S for Sarah, I for G, Indigo, G for Golf, G for Golf. Sparse missile represents a paradigm shift from traditional weapon systems. The system is a multi-purpose payload developed using phenomenology navigation, radiographic prediction, and command intercept capabilities. This document analyzes the second architecture and the integration within open sense frameworks. Let's read it. It's not a toy, guys. Don't play with my whistle. Don't play with it. That's very important. Don't play with it. Uh, So, I don't like putting child food clothes there, but I had to do it because of, I was a child. That's obviously when I was a child, that's a had this idea. So the child food clothes are there in the section because I was a child and had this idea. I had a toy soldier, and a toy soldier was a man. So I had a toy, something else, no toy, it was a toy. A toy soldier, which was like a toy soldier on the post. And he was just always come, It was a green toy soldier. And I thought something about this, the toy soldier, yes, it's a soldier, but it's a toy. So I had to play with it, and then I had a toy dragon. So that's my toy story as a child. I played with that toy as a child, but I really get to play with the child because I'm a mom. But this is the child city because it's really like it means like a toy, but it's basically to trick you. So don't be fooled, guys. But it's a safety on them. So this is what I'm saying this now. This is my disclaimer. Prevention before care. Control logic. So the Tomo missiles are the most annoying missiles in the world because they measure they're dimensionless when you are measuring your depth when you're trying to hack a someone. So this can be a tomahawk missile in flight. On flight, getting to you're measuring your depth. You just know this in the between time. That's the time you're measuring. Let's say you're measuring your depth, guess you're measuring dying. That's when you try to intercept one. So this why this came in, but it's basically annoying to see that people are not innovating anymore. So I took the initiative to innovate. So we're gonna look at the specs now. Kilometers, 1,500 miles. That's that can destroy me. That can destroy one triplex. One triplex. One triplex is 1,000. 1,000 times 7. Okay, one compound. Uh, Essentially, this one compound times 3. This is one triplex. So there's one, 3, 1, 2, 3, 1,000, which is 1,500. And destroy it. Insane. And it has the range. It's the range it travels. But, the travels so it can destroy it. Insane. Yeah. Yeah. That's part of it. 8,000 is subsonic. Half of sonic. So basically, you get subsonic, you get sonic. So if you go find the sound barrier, which is Mark 6, Mark 4, no, Mark 4, 6 is the sound barrier. So basically, the speed of sound is half of light. It's half of light. So the speed of sound is half of light. Light travels so basically, most of it is like at 8 minutes to get to the sun. That means sound travels at 4 minutes. Four. So I did 8 minutes basically 8 times 2. Look how I did. 8 times 2. 8 minutes is from the sun to reach us eight light years away. 8 minutes light years away. It's like 8 over to 16 light years away. 16 minutes in light years away. So that'd be 16 to light years would be how many light days. It's just 16 minutes away from us. The sun, from the sun. That was the subsonic. That's what I'm giving you some. This 8,500 is really soft as half the size, half the speed. Sound. So it sounds. You use to do like sound sonar to pick it up. Uh, the page is responding. Wait, let me just refresh the page actually. We pick up where we left off. It should not, yeah. So let's continue. Okay, so it's not working as intended. So let's take this charger. This has a problem. Yeah, so we're gonna range subsonic text preferences center uh, text spacing. Oh, text spacing is good. Yeah, so you get text spacing here. Oh, there is you can inverted colors, inverted grayscale colors. You get some you yeah. Sorry about this, guys. If I'm on the spec now. So now let's resume. So it's here. So the race hugging. So race hugging this layer. You get a turn hugging 30 meters in the air to 90 meters in the sky. Literally, they have you have a longitude which wraps around the surface of the geometry of the Cancer, the working equator. So the longitude is the equator, triple Cancer, which is on top of wait, let me try to find Tropic of Capricorn. Capricorn will be latitude. Yes, southmost, northeast. To get to tropical at the bottom, yeah, you get the message here. This tropical is really an equator, but this is still working the equator system, so it's all geography basically. Once you get to the sense, so this is equator, this is tropical, you get to Cancer here. So Cancer here, cutting North America and Jamaica, and get Nigeria and equator. Yep, that's what I'm saying. So you get that there. It's basically becomes mathematical, geometrically lattice. You use it to to go level to move roughly the system sparse state. Back to the article now. So you get terrain hugging of altitude. So you get altitude will be the longitude and the latitude. So the altitude will be the latitude referring to, and the longitude, latitude, and that's referring to the altitude. That's not altitude mean the height. But it's terrain. I'm gonna what's called terrain hugging systems. So let me continue. So you get GPS guidance like GPS can be in Terracom. And this Mac, I don't know about GPS is like we're using cars to navigate cars, GPS guidance systems, telecom, uh, terrain communication, and which I believe this Mac, which are Mac address industry systems. So what is this Mac? Digital terrain counter matching. Yeah, yeah. It's a counter basically. It's basically an ability to prime to counter mapping for the counter mapping. Radar. Yeah. So, yeah, so it works with an altitude, but the telecom is uh, telecom. So you get telecom. Then you get this Mac. Now this Mac is one of those. Uh, this Mac is digital scene matching area correlation. So this is a early form of AI. So this Mac is an AI system. It's an early form of AI, very early form, but it still works. So so if you get cost 1.64 million each. So other than that, so just look at the cost you see. Ooh, that's what I said. So, so it's basically these are the weaknesses here. It's basically why I don't hate the tomahawk. I just hate that it's also. So I'm looking at things that are inhumane, which are a lot of weaponry, and I'm trying to bring them to the ground, literally, to the knees. That's what I'm trying to do here. I'm trying to again. So I'm trying to take the weaponry that are inhumane, up to the being to the knees, and does include the tomahawk, anything that only kills people, because at the end of the day, it's gonna fall, it's gonna fail itself, one way or the other. Uh, Thank you guys. So let's continue watching the video. So I've been 17 minutes here, so let me continue. This is something. Yeah. So it's basically it's critical dimensions. Because it's so fast. You're measuring your depth when because it creates a space that it holds because that space is the dimension ahead of it. Like it doesn't. It's an air system, so it was so fast that it starts to cruise and you can between the you can't accept it with someone else. You one step. You think it's here. You think you're entire one dimension behind. So you're like one entire step behind the missile. One every time you think you're there, you're insane. Too late. It's too late. It's actually very sweet. So So this is my one. So the my one launches uses click on this activity about this tomorrow. So my one has a launch a hoop. So it's a hoop time is climbs. Because basically it has time and climb is basically the latitude and altitude of the system. Which means to determine the kind of curvature. But the shortest parts stop. The shortest parts slicing, like even orange, if you know about if you know about aircraft carriers, if you know about aircraft, planes, they take curves, they go in the sky and they come down slowly, but uh, it's supposed to take to go in the air and then come down. They go in the air and come down, go in the air and come down. So they take a curve, but that curve is their shortest path. In a lattice, like a geometry, like post up, if you take a wireless or managed route, a metropolitan area system, and you slightly take an orange, and you slice that orange through the point from point A to point B, uh, that the curve the orange makes is the shortest path between those 2 points. So if you take a new orange and you have a knife and you slice the orange with a knife, that's the shortest path between that orange, and that orange. And that's what's happening with well. You can't just put a straight line on it because it's a curved geometry. So it's not going to work in the end. And that's what the missile is doing here in the cruise missile. But this one's basically not safe. So this one, the one that does that, yes, but it's not safe. You have to, it's not safe. It's fast, yeah. So the problem is so it's not. It doesn't. Thomas does not do that. So it launches, it cruises, but it constant altitude. So this is not safe because it can be intercepted. So that's the proof. That's the hypothesis. It can be intercepted. So it can be intercepted. It can be hacked. It can be hijacked. Because it has a constant altitude. It may be one dimension behind, but if you get the timing right, you know where the you can hijack it and dispose of it. And say, or use someone else's time or something else malicious. So they would terminal that some the launch, it cruises, and they had terminal dive. It's very annoying, but that's what it does. It's not safe because it has a constant altitude, and that constant altitude does not cut between two orange and okay. If you take a knife and you have an orange between 2 points, any 2 points of orange, you slice it that's the shortest part. Remember, that's the shortest part you take on the surface, and that's the integration you have to make between so you have to make the inverse integral space. So the shortest part to make so you have to have if you draw a straight line where that knife has cut to the point, a straight line. That's where the integral and that section of the orange is the separation of the orange of the part orange and the orange is the integral, and that's the integral you have to take mathematically to get the shortest part because it's a lattice. It wasn't dynamic, via lattice and longitude. So the thermal is in that aspect, and then you get the launch hoop, which is my one. So my one has a climb. Okay, so you have read around from here. So you have let me just read this out. Okay, so you get continue reading from here. Okay, so hoop one is climb. So that gives you ascension, descension. And hoop two is like a safe ascension. You get ascension, descension. Because if the mission fails when ascension, it's just fall down. If you fall down, your head or your body, you're gonna be doomed without all that fuel. Okay. You have safety measures here, but still a safety risk. So you have to ensure that it leaves your atmosphere, the area you are already in, using on that like geometry, or on that orange area. So hoop two loop, hoop two basically. So hoop two is a loop, and that loop is basically like how many loops, how many spins you get, the journey to target, or the speed you're going to get to the food. This is called a loop. So the loop is basically am I going to deliver the payload for hostiles or humanitarian aid for humans who are caught in the loop, not in the loop, caught in the loop. So in the fighting or in the war. So two is the loop. So you can loop twice or take it from direction to one part to do it. And you get hoop three, the same. So let's look at the descent. Yeah. So descent is really the safe delivery of the system. But this one works by eggshell. So there's two types of descents. You have descent one, which is basically the safe descent, which is like uh, four types of defense actually. So you have the kinematic descent, fast delivery of payloads such as humanitarian aid. You have type two. So you have type one, And type 2, fast. So basically, if you have an egg and you drop an egg, basically, they can deliver like a parachute, and the egg is basically the payload. If the egg is like is a parachute egg, the egg is wrapped in a bubble wrap, and the egg is descended, but there's some kind of force that's kinematic, so you can have to wrap it to you have inverted kinetic force, you have force acting on the egg to slow it down, but to protect the egg, you have to make sure the egg doesn't explode once it hits the surface. So that's the problem of the system. This is really a child's project here to wrap an egg in bubble make sure you protect it with the science lab equipment what you provided, in lab, and that we could do it. So the kinematics of the system is that the egg is protected because the egg is like bubble wrap, which is the food, and the egg was the food in this case. But because each type of delivery product, you have four main types of deliveries. We have let's say eight main types actually, because you got like the attack vector on the system. So you get delivering the egg safely and therefore to humanitarians without delivering to the wrong person. That's what you want to deliver to right people. Right people who need the food. And this works by having the force called the inverse kinematics system to slow down the payload whilst the missile is basically delivering the service. But it's not actually the missile that's moving because the main missile does the loop. And the mains can split and do hoops and loops. So you go in loops, you can do loops. So the loops basically have to discharge on the system to the job. You can use this is normally to deliver Manchester software. So you get hoop descent, and descent is the safety protocol for the system. And you get if it's an egg in bubble wrap, or if it's like something like a something traveling to time. It's meant to ensure that there's a time access via gimbal. So the gimbal is what so the thing was in the gimbal, and the gimbal is basically a dimensionless quantity, like a compass gimbal. So it takes a kind of form of gimbal, with which a pitch, roll, yaw, via the loop, and the loop determines how the system so roll, which is x-axis gimbal switch. But basically the gimbal's not cochainer, but the gimbals work on lock. So you can have a gimbal lock on, and when the gimbal lock, that means you hit a target. You hit a target. So you're already locked into a target. But, you can lock on without a gimbal. So there's a gimbal system to lock on to people that are there, and that's how it develops food. So when the gimbal locked on, that's just basically that's the payload, but it's not using AI intelligence. It just have a lock via the gimbal, and that's the payload. So it's not a target lock; it's a gimbal lock. So the difference between a gimbal lock and a target lock, if you together, is a gimbal lock is basically a system of having again. So you have how this works. So the gimbal works by oh, this is done. Oh, this is good. So I'm gonna do some more timer for 20 more minutes now. So we have a gimbal lock. So the gimbal is basically the target. Well, the target can be a human or something, but the target has an area and a shape, and one has an area and and the area basically have a like the land area to the food. So it's basically meant to be safe when it arrives to the ground, and that's basically what the gimbal lock on is meant to do. Again, have the gimbal lock on. So the gimbal lock can also be used as if you don't want to, but it just depends on the there's no human controlling it. It's just because you don't need human controlling the gimbal. The system just locked down. It's all pre-programmed. It's all pre-programmed, and it just knows who to give food, when to give food, what time of day to give food. With a smart space or something, you can adapt on the fly based on the weather or something on happen. So the hoops are the important things, but the gimbal is the thing that determines whether the axis, the system goes up or down, rotates, changes axis, changes longitude and latitude, based on the dimensionless quantities, which are like one shared axis of dimension, what we call a row gimbal, which is like an x orientation, because they work on orientation and electromagnetic electromagnetic properties, electrolysis AC, electrolysis with alternating current. But the goal of this is to have a system gimbal lock on X, Y, Z, but pitch, roll, pitch, which is the latitude, and yaw, which is the sway in the y gimbal, which is the Z gimbal. So yaw is the rotation of the Z gimbal, and that's how I was. So you get the delivery system here via hoop 2 descent, and hoop 3 is basically descent, the safe descent. So you get two types of descent, which is like a safe descent, like a gimbal descent, the safe gimbal descent, you get like kind of sparse descent, descent is for the food. It's protective. It's more like you can slow down. It's more like a slow down, and it's acceptable. It allows you to go and catch the food, catch it, and allows you to like make sure to, when it's kind of altitude, you get deliverable, and for the food, you get the other one, which is like the missile to neutralize a threat or target, or some kind of a robot, or some kind of humanoid entity, something that can't observe the state at one frame in time. It's not a gimbal. It's a sparse or something. This is how it works. So realistically, so you have the hoop two, which is the apex, the highest part of the apex. So happens to you get root right left, root right left. Home launch, but root right is the right pointer of the game is the launch. But who wants launch, who choose apex and choose zero. But the apex has descent and delivery. So the descent delivery is really dangerous. The gimbal lock, you get the missile lock. So you get gimbal lock, you get the missile lock. So the missile lock is basically what you choose to target. Because it's a missile that locks down the system. But it's a descent protocol. So they are split into systems of steps of A, B, climb or descent. If it's an ocean missile, climb or descent, because you have the flip, so descent, but if you're in the ocean, so hoop three developable. So why? So the hoop one, so descent basically, if you have the missile and the missile's on safe, how would you know delivery? No, you don't have to know. You just have to have the compartment separate from the. You have like a clear flags. But the descent is very good. You have a parachute, but I don't have a parachute. The most you travel at standard speed, but to will be useful. So you can have the missile fire to one missile, one missile, and one gimbal humanitarian aid and descent, one gimbal lock missile, and they will still descend relative to the uh, relative to whatever was in front of them. Because English came to work on things. If a car, and the car has a human being in front of it, English came to slow down the car because there's a human in front of it, and that's what the egg is doing. But it will speed up. It will speed up if it's an AI song, if it's like a hostile entry, like a tank. It will speed up. It knows how to work with the environment or the terrain it's in, and that's the goal of the system because it's very dynamic. But it's very dynamic. So you get the one, you get hook two, and you get hook three. And these are the apexes of hook two. And this is the river. So why multiple hooks? So vision to you get hook one. So see hook one, hook two, hook three. So hook three is usually based on open github.com slash ODTS, but this is how it works in practice. So the ODTS repository is what it does. It's very, very good. It works in dimension quantity, so you can only mention the dimension. There's no degree. So you get the third derivative, which is 18, but 18 is space of time, so you have to have 18 to the jerk. But the jerk, you have this does, so you have the third derivative 9t squared plus 4yt plus 7, 7. And this share, you get the second derivative, which is 18t plus 4. And you get 18 seconds, 18t, 18t, 18, but 18 is divided by 2. So you get 18 divided by 2, which is 9. So you now get 9 seconds, 9 dimensions, 9, so the sheer unit of 9 space and 9 time, 9 dimensional space and time, to compute a termination point, but you don't have to, so you take the space and the time, because to form together, so you can have a third derivative, but you want to calculate the derivative in the jug, you could just do. So let's continue, because you can watch the video on the OBS derivative framework later. Blood goes down. Okay, so it's not so you get components breakdown. Two missiles, five again. One missile safety. This is the old spec, but it's gonna be hard to because what so I'm gonna have double is 4 missiles fire forget, 5 missiles forget and fire, but forget and fire because they're defensive. So forget and fire we get 4 humanitarian aid stream, and we get four. We're gonna have uh, to get a business. Can use the drone. So 4 humanitarian aid to be drones attached, mini drones. And so maybe resource drones, so like drones on the system. Humanitarian aid really can be drones too. Because humanitarian aid are drones, normally drones in the front end. So I want things that can deliver quickly. So drones are the best you want to do. Because you can coordinate them. So I'm gonna have let's say we have put 5 drones here that can carry some kind of weight of so if an ant can carry 5 times 3 times body weight, this drone will carry 2 drones will be able to carry 100 kg with no problem. 100 kg. No, no, 50. Okay, ants can carry 50 times body weight. So if an ant can carry 50 times body weight, do I have 4 ants? 50 times 4 will give me 200 kilograms. So, so I'm looking to carry 200 kilograms, 200 kilograms, uh, 200 kilograms of rice. So, so 20 kg. So, this 20 kg. So, if you just like carrying root, so this is 20 kg, well, 200 kilograms of essentials. What does that look like? So this is how 200 kg looks. So it's basically four or something. If I do 100 kg, 50 times weight. So if I ask you 15 times, so 50 times weight, 50 times weight. So I want to have two, something that's double that can carry two. So if I have 250, so two drones that can carry 100 times the weight. I mean 250 times the weight. So two drones. Let me just have 4 drones, two spares. We have 4 drones total. So 2 drones are used at a time. And we get four spares, four missiles as drones. Basically, there's the humanitarian aid devices and missiles of self-repair and self-hack defense. Some cyber defense, that can repair the missile on the fly while it's flying. You know, and get them to the target. So basically, 8 missiles for humanitarian aid crew and self-repair. For the missile itself, you get 2 missiles for fire and forget. So you can have 3 missiles for fire and forget, and 3 missiles for forget and fire, respectively. So you can intercept something. I'm not doing that stuff, but so this is the old spec where it's basically meant to be carryable to system, without dismantling in the air. If it dismantles in the air, then I failed. Then I failed this kind of project. But it does work mathematically. So it shouldn't dismantle in the air. So let's continue here. So we got this one here. Yeah, we can look at the matrix. Cool. It means area scanning. Oh, so this pseudocode, if this is a player selection, it's about some original shell. So you can see here, this pseudocode is in Python, but it's not really. So you get if detection of underscore civilian underscore area, colon, payload switch to humanitarian aid, colon, also LF, detect incoming missile, which is a function, uh, initial function, colon, payload switching into tell mode, and then it's really meant to, it's really meant to missile defense, because it's really for systems on the ground, I'm thinking about missile defense. Um, this kind of context here, but I'm thinking about the US past model too. But it's not just for things on the ground, these things that are moving in the sky too that we don't know of. We can call you unidentified aerial phenomenon. We get a single jamming, spoof attacking, and the wide satellite object detector. So, NSIGGI alternative is the system here. So, it's basically it usually but it does work on system of stuff. So you have a signal. So usually don't worry about this. Usually you want to have no blind spot, no different different, and that's what radiography is important. Because it's really radio waves where you can have all the colors modeled there. You don't have the same no different delays, because it's radio waves. And it works on the system of radio. So my video 42 minutes. So you have aux star, OX star. So the signal, yes, yes, yes. So you get noise start. So you get uh okay. So you get AUX start. So you have this is the way to start. So so you get aux start. But these are just like signal, noise, no noise. But based on the system, we get auxiliary start, which is the system has to start based on human input. Or some script that's been delivered. Auxiliary on the fly system just start based on the dynamic structure. Or you get noise start, no noise start, no signal start, which is the three trident comprises. But you have to determine what the start sequence is to have an aux start. And aux start with the human coming is not needed. You have an aux start. So the signal, yes, there's noise, yes. And the aux start is actually the difference between noise and mass. That means something wrong. Um, and that's just the automation version. These are just state machines, verification state machines. So I'm gonna stop this video now. If I don't stop it, I'm not going to allow this to TikTok. Thank you very much for watching. Have a lovely evening and goodbye. Because if I don't stop this video now, I'll never stop this to TikTok. Thank you very much. Bye.